Hi, my name is Kate Berry from the University of Texas at Austin. Welcome to this video from our multi-step word problem intervention featuring total, difference, change, and equal groups problems. In this video, I will model how to set up and solve two different types of multi-step total and difference problems. Let's first take a look at the 5 components of our intervention. In our multi-step word problem intervention with total, difference, change, and equal group schemas, we have 5 lesson components: captain cards, equation quest, Buccaneer problems, ship shape sorting, and our Jolly Roger review. When students set up and solve word problems, these primarily take place during the Buccaneer Problems Guided Practice Activity, as well as our Jolly Roger Review Independent Practice Activity. But primarily, students are practicing setting up and solving word problems during our Buccaneer problems. So I will focus our attention on Buccaneer problems featuring the multi-step total and difference problem. Let's take a look at the materials you will need. First, you will need your multi-step word problem schema mat. We have 4 different versions. Here we see version 1. This is the one we will need because for total and difference problems, these are our first 2 single-step schemas. So when we introduce multi-step problems, we're going to begin with our total and difference schemas. So in addition to this multi-step schema mat version 1, you'll also need your Buccaneer problem worksheet, a pencil, as well as our What Do You Ask Yourself poster. So here it's a great opportunity for students to think about the different problem types and to think about which problem types we're using. Because this video is featuring multi-step total and difference problems, you only need to focus on the first 2 questions on the What Do You Ask Yourself mat. We have 4 different types of multi-step word problems that we introduce in our multi-step word problem intervention. I did an inventory of the standardized tests and made a list of the most commonly seen multi-step word problem types, and we came up with 4. We have total and difference multi-step problems, total and equal groups multi-step problems, equal groups and equal groups multi-step problems, and equal groups, and total or equal groups and difference problems. Again, the focus of this video is going to be this first type of multi-step word problem, our multi-step total and difference problem. So now let's take a look at the 2 multi-step equations that students might use when solving a multi-step total and difference problem. This is kind of a zoom in of the poster that you saw on the large multi-step word problem mat version 1. So here we have 2 different equations. Here it's almost like our total schema and our difference schema got married and came together. So students will use our first equation when the combined amount is greater. Students will use our second equation when the combined amount is less. So our first equation says, open parentheses, P1 plus P2, close parentheses, minus L is the same as blank. This stands for part 1 plus part 2 minus the amount that's less equals blank, or is the same as blank. And we can also think about and talk to students about how this P1 and P2 is really like our G or our greater amount. So we're going to use this first equation again when our combined amount is greater. We'll use our second equation when our combined amount is less. So this equation is G minus, open parentheses, P1 plus P2, close parentheses is the same as blank. So the greater amount minus part 1 plus part 2 is the same as blank. Here again, we can talk to students about how this P1 plus P2 is really like our L or our lesser amount, and that's going to help them understand that we're going to use the second equation when our combined amount is less. So let's go ahead and get started and solve 2 examples of multi-step total and difference problems. Again, here we're going to utilize our equations, thinking about is our combined amount greater or is our combined amount less. So let's go ahead and practice solving a multi-step total and difference problem. Let's here take a look at our word problem. Before we even read it, we want to check to see if there's a table or a graph. I don't see a table or a graph, but if I did see a table or a graph, I would number it. So let's go ahead and write our attack strategy on the side here so that we know what our steps are. Now that I have written UUPPSS check check, let's get started with our U. Our U stands for understand by reading. So let's read the problem. It says, Ray has 14 blue shirts and 34 red shirts. Ray also has 22 pairs of pants. How many fewer pairs of pants does Ray have than shirts? I feel like I've understood the problem. I'm going to check off that U and move to U, the second U. The second U stands for underline our label. Most of the time we can find our label or what we're talking about in our question sentence. It says, how many fewer pairs of pants does Ray have than shirts? Well, they're asking us about pants, so I am going to underline pairs of pants in my question sentence. I've underlined my label. I'm now ready to move to my first P. Our first P stands for put our numbers in order. When we have single step problems, this is pretty easy. We're just putting a 1 above our numbers. But when we have multi-step problems with more than 2 numbers and more than one thing going on, we have to think extra hard about what's happening and put a 1 above what's happening first and a 2 above what's happening second. But before I do that, I'm getting a little ahead of myself with putting our numbers in order. We first need to put parentheses around the numbers that we need before we put them in order. So let's scan our numbers. Our first number is 14. That's about shirts. It's not about our label pairs of pants, but I know we're comparing pants to shirts, so I'm actually going to need that. So I'm going to put parentheses here around 14 blue shirts and continue scanning. My next number is 34. 34 is about red shirts. Again, I'm comparing the pants to the shirts, so I need that. I'm going to continue scanning. I see 22. That's about pants, which matches my label, so I definitely need that number. And now we have put parentheses around our needed numbers. We don't have any irrelevant information. Everything is related to pants and shirts, and that's what we're comparing here. Now I got a little ahead of myself, but now I'm ready to put my numbers in order. So I need to, again, think really hard about what's happening first in the problem and put a 1 above those numbers, and then think about what's happening second and put a 2 above those numbers. So let's reread our problem to help us. It says Ray has 14 blue shirts and 34 red shirts. Ray also has 22 pairs of pants. How many fewer pairs of pants does Ray have than shirts? Well, first I need to figure out how many shirts Ray has. So I'm going to put a 1 above 14 blue shirts and a 1 above 34 red shirts. After I figure out how many shirts he has, what I then can do is compare those to the number of pants. So I'm going to put a 2 above pants to let me know that 22 pairs of pants is involved in my second step in solving the problem. Now that I have put those numbers in order, I can move to my first S. My first S stands for schemas. So here I can look at my what do you ask yourself poster. When we first introduced total and difference problems and multi-step total and difference problems, students have only learned total and difference problems. But later in our curriculum, they're exposed to all of the problem types, and then we combine the different multi-step problems. So I'm going to read all 4 questions on our what do you ask yourself poster. We can say, are parts put together for a total? Are 2 amounts compared for a difference? Is there a starting amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? Let's read our first sentence. A lot of times it's helpful to break apart in sentences for students. It says Ray has 14 blue shirts and 34 red shirts. So I know first I'm putting the shirts together. I need to figure out the total number of shirts. I have red shirts and blue shirts, and I'm putting those together. So what I'm going to do is I'm going to put a 1 and then a T. This tells me that my first step in solving the problem is using the total schema. Then it says, how many fewer pairs of pants does Ray have than shirts? Here I know that I'm comparing pants to shirts. Here we have our compare word fewer that may indicate that we're comparing. So we have pairs of pants, which is our amount that's less, and shirts, which is our amount that's greater. Whenever we're comparing, we know we have a different schema. So I'm going to put a 2 and a D to let me know that my second schema involves the difference, or my second step rather involves the different schema. Now before I move to my second S and solve this problem, we need to look at our multi-step word problem schema mat to see which equation we're using. Remember, we use our first equation when the combined amount is greater and the second equation when our combined amount is less. So we know when we're combining, that's the total schema. So we're combining 34 and 14. I can do a little mental math and say if I'm combining 34 and 14, that's going to be greater than 22 pairs of pants. So my combined amount is going to be greater. Because my combined amount is going to be greater, I know that I'm going to use my first equation here. And my first equation is open parentheses, P1 plus P2 close parentheses minus L is the same as blank. Now we have figured out our schemas. All that's left to do is plug in our numbers. So here, what we're going to do first is always in parentheses, and we can look back to our ones. I know I have 14 blue shirts. I always like to check off my numbers after I use them to let me know that I'm finished with those numbers. My one is looking a little squirrely here, but that's all right. The next number we have is 34. That's the other type of shirt that we are combining. And then my amount that's less is our 22 pairs of pants. So I'm going to put that right here, check off that number. And now I'm going to add my signs and my parentheses. So here my parentheses, and I'm adding because this is our total and our subtraction for the difference portion. If you want to, you can check off your 1T and 2D after we have put those numbers in the equation. Now, in our program, we talk about the order of operations. We teach students that parentheses come first in the order of operations. So when we're looking at this equation, we see 14 and 34 in parentheses. So I know that's what I need to do first. I'm going to go ahead and line it up, or you can do the mental math. Draw my line, circle my sign, put the greater number on the top. 4 plus 4 is 8. 3 plus 1 is 4. So 48. Our sum is 48. It's running onto the poster down there, so I'm going to write it over here so you guys can see it. Now all I need to do is subtract 48 minus 22. So again, you could do the mental math, or you can line it up like I am. Draw your lines in between our place value columns and circle our sign. 8 minus 2 is 6. 4 minus 2 is 2. So here I'm not finished. That number answer is going to get really lonely if it doesn't have a buddy. So here, I'm going to write my number answer. Then I can just look back to what I underlined. I underlined pairs of pants. So now I have my number answer and my label answer. I have solved the problem. The very last thing we need to do is check for reasonableness. I need to check my number answer and my label answer. Here, it makes sense that my sum would be 48 when I'm adding these two whole numbers, and it makes sense when I subtract 48 minus 22 that my difference would be 26. We can also have students do the mental math or check it by doing different variations of math on the side, but here I'm pretty confident that my number answer makes sense. The last thing I need to do is to check my label answer. Here, pairs of pants matches what I underline in my question sentence. So here, an important thing to think about is that we want to use this multi-step total and difference equation when our combined amount is our amount that's greater. And that may require students doing a little bit of mental math as we're setting up our equation. Now in the next slide, I'm going to show you what it looks like when we solve a multi-step total and difference problem when our combined amount is the amount that's less. Now let's take a look at a multi-step total and difference problem where our combined amount is less. As always, we're first going to check for a table or a graph. I don't see a table or a graph, but if I did see a table or a graph, I would number it. So let's go ahead and write our UPS check squared attack strategy on the side of our page here. UUPPSS check check. All right, let's go ahead and start with our U, which stands for understand by reading. Our problem says Julie is making soup. She uses 3 pounds of carrots, 3 pounds of onions, and 7 pounds of chicken. How many more pounds of chicken than vegetables did Julie use? I feel like I understood the problem, so I'm going to check off my U. And now I'm going to move to my second U, which stands for underline our label. Most of the time the label can be found in our question sentence, so I'm going to reread that to figure out what our problem is mostly about. It says, how many more pounds of chicken than vegetables did Julie use? Well, this story is asking me about pounds of chicken. So I'm going to go ahead and underline pounds of chicken. I'm going to check off my U. Now, if you want to check for irrelevant information during the second U step, you can, but you can also check during our first P, which stands for parentheses needed numbers. So what I need to do now is scan all of my numbers and make sure they're talking about or related to chicken. I also am going to think about numbers that are talking about vegetables because I know that I'm comparing the chicken to the vegetables. Now, if your students don't eat anything green and they might need a refresher on some vegetables, this might be a good teaching opportunity for you to review some English vocabulary with them so that they can understand that carrots and onions are types of vegetables. So let's take a look and scan our numbers. Our first number is 3. This is about carrots. Well, carrots is not chicken, but it's a type of vegetable. And I know I'm comparing chicken and vegetables, so I'm going to need that number. So I'm going to put parentheses around 3 pounds of carrots and continue scanning. My next number is 3 pounds of onions. Onions are my very favorite. Here, they are a type of vegetable. Again, I know that I need that number. Again, this might be a good teaching opportunity for your kiddos if they don't know that onions and carrots are vegetables. Our next number is 7, which is about pounds of chicken. And I know that my label is about chicken, so I definitely need that. I don't have any more numbers. I can check off my P. I have put parentheses around all of our needed numbers. Now our next P stands for put our numbers in order. When we were working single step problems, we only needed to put a 1 above a number. But now we're working multi-step problems, so we need to think extra hard about what's happening first and what's happening second. So I'm going to reread the problem. It says Julie is making soup. She uses 3 pounds of carrots, 3 pounds of onions, and 7 pounds of chicken. How many more pounds of chicken than vegetables does Julie use? Well, first I need to figure out how many pounds of vegetables she has. And I know that carrots and onions are the vegetables. So I know that I'm combining those amounts and I need to find out the total number of pounds of vegetables first. So I'm going to put a 1 above the 2 numbers that are talking about our vegetables, which are carrots and onions. Then I'm going to compare those to the pounds of chicken. So I'm going to put a 2 above pounds of chicken to remind me that that's my second step in solving the problem. I'm going to put a check mark next to my second P. I've put the numbers in order. Now I can move to my first S, which stands for schemas. So I always want to look at my what do you ask yourself poster and ask our questions. Are parts put together for a total? Are 2 amounts compared for a difference? Is there a starting amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? Here, I'm combining first because I have the pounds of carrots and the pounds of onions to find the total number of vegetables. When I'm combining, I am putting parts together for a total. So I know my first step is going to involve the total schema. After I find out the total number of pounds of vegetables, it says, how many more pounds of chicken than vegetables did Julie use? So now I know it says, I'm comparing pounds of chicken to pounds of vegetables. More is one of our compare words, so sometimes we can use those words to think about, are we making a comparison? And here we're comparing chicken to vegetables. So when we're comparing, we know we have the difference schema. So here my first step involves the total schema. My second step involves the difference schema. But I'm not finished. Before I can move to my second S of solve, I need to look at our multi-step word problem mat version 1 to figure out which equation I'm using. Remember, we use our first equation when our combined amount is greater and our second equation when our combined amount is less. So let's think. We might need to do a little mental math here. 3 and 3, that's my combined amount, is 6. 6 is less than 7. So I know the numbers I'm combining are less than my greater amount. So here, because my combined amount is less, I'm going to use my second equation, which is G minus, open parentheses, P1 plus P2 is the same, close parentheses, is the same as blank. Now I can check off my S. If you want to check off your 1T and 2D, you can feel free to do that. Now all I need to do is plug in my numbers. I know that my greater amount is the pounds of chicken. It says how many more pounds of chicken. So I'm dealing with pounds of chicken as the greater amount. So I'm going to put that under my 7, or my 7 under the G rather, and check off my number. And now my P1, we said we're combining carrots. There are 3 pounds of carrots. And we're combining those with the pounds of onions. So I can put this another 3 under that, check off my number. Now all I need to do is bring down my parentheses and my signs. We teach students about the order of operations. We're really preparing them for algebra. Here, I know that whatever is in parentheses is what I do first. I know 3 plus 3 is in parentheses, so I'm going to go ahead and add that. 3 plus 3 is 6, so now I'm just going to bring down my 7. 7 minus 6 is going to give me 1. Now that number is pretty lonely, it needs a buddy. Let's go back to see what we underline. We underline pounds of chicken, but we only have 1, so we're gonna write pound. Pound of chicken. I have my number answer and my label answer. I have solved it. But my very last thing I'm going to do is check for reasonableness. I need to make sure my number answer makes sense and then my label. So here, if we add 3 plus 3, it makes sense that the sum would be 6. And if we subtract 7 minus 6, it makes sense that the difference is 1. So I feel pretty confident that my number answer makes sense. Let's check my label. Here it says pounds of chicken, and that matches what we underline. Nice job solving this multi-step total and difference problem where our combined amount here is the amount that's less. Again, to help students figure out which equation to use, you may have to do a little mental math like we did here, but really helping them talk through and figure out whether the combined amount is greater or the combined amount is less is going to help them figure out which equation to use. Thank you so much for taking the time to view this video where I demonstrated how to solve multi-step total and difference problems. I'd like to take a moment to thank the Institute of Education Sciences, the University of Texas at Austin, and the Meadows Center for Preventing Educational Risk. Without their support, this work would not be possible. I'll see you in the next video.